Okay, so the whole point to organic synthesis is to make valuable complex compounds from cheap and readily available starting materials. So, that may not have been obvious up to this point what we're doing, but we're actually taking something like this, a primary halide, and we're making something kind of cool out of it, right? And all we have to do is we've got to bring in a nucleophile that looks like that. There's my nucleophile. I got my leaving group right here, right? Or if the nucleophile is acetate, we're going to make an ester. If the nucleophile is SH, we're going to make a thiol. If it's methoxide, we're going to make an ether, right? So the whole point, I'm repeating myself, is to make valuable and complex compounds. So let's think about this. Now, if we've got, I guess another example would be a tertiary alkyl halide. If you have a tertiary alkyl halide, we treat it with a big bulky base, a strong bulky base, and we're going to get an alkene. If we treat it with a small strong base, we're going to get the Zaitsev product, right? So these are all reactions which you've memorized up to this point. So when we're thinking about how to make something, this is counterintuitive, and lots of students actually find this very uncomfortable in the beginning. When we're thinking about how to make something, first of all we think about what we want in the end. What's it going to look like? So Dave Klein uses this, I think, a really good sort of analogy. If you're building a brick house, you don't just start with the bricks and say, what can I make with these bricks? You think about the house, and you decide what bricks that you need to use to make it. And we're going to do synthesis exactly the same way. Now, since we're doing it that way, we're going to call it retrosynthetic analysis. All right? So here's how we're going to do it. We're going to be calling retrosynthesis, and we're going to be thinking of the product, and we use a backwards arrow like that. And that arrow can be interpreted as can be made from. So Y can be made from X. That's what this means, okay? And we're going to use this a lot. So in retrosynthetic analysis, first thing you do is you identify a bond in the target molecule that can be made using the reactions that you know. So for example, if you're trying to make an ether, then you say, well, I know how to make that bond right there, right? Then after you do that, you draw the substrate and the nucleophile necessary to make that. So I'm going to go 1, 2, 3, 4, and 5. So I'm going to go 1, 2, 3, 4, 5. And then I just need a leaving group, right? So if that could be a nucleophile, and I just need a leaving group. So I'll say, well, let's let bromine be my leaving group. And I see if that's my nucleophile, that's really just going to be ethoxide, right? So ethoxide, as you've memorized already, is going to come in, do backside attack, and we're going to have an SN2 reaction, okay? So again, first thing we do is we identify a bond that can be made, and second, then you draw the substrate and the nucleophile necessary for that reaction. So there are two carbon-oxygen bonds in ether, so you could have made either way, right? You could have made this be your substrate, which that could be your alkyl halide, right? And then you could have had this other alkoxide. Sometimes it'll work both ways, and sometimes it won't, right? So this is, don't forget, sodium is just a spectator ion, so this is just sodium. Suppose there's 3 pairs of electrons there. This comes in, boom, backside attack on that carbon, boom, SN2, right? So you'll find that when you're thinking backwards like this, one reaction will oftentimes come to mind to make a target compound. When there's more than one possibility, that's awesome. That's even more fun. Now, step 3, after you've done step 1 and 2, by identifying a bond that can be made, identifying the reagent, step 3 is you verify that the reaction is reasonable. So we come back here now and we say, all right, I've got a primary halide. That's a good substrate for SN2. I've got a strong, unhindered nucleophile. It's not bulky. That's also good for SN2. Yes, this is going to work. And then we draw the reaction in the forward direction. Okay, so this is the last thing we do is we just draw it out. And we say, is this legit? Now, for SN2, you want a polar aprotic solvent. So we choose one from our toolbox, polar aprotic solvent, and bam, there you have it. Okay, this is going to require a lot of practice. I encourage you to start by taking these reactions. Let me go back to the first slide. The primary halides and the tertiary halides, and making up a reaction. So suppose, for example, I'm suggesting to you what you ought to do is you ought to say, how would I make that? How would I make it, right? From anything, but you only know one thing right now that gives you that gives you a limit. You only know one reaction that's going to give you an alkene, right? And that's elimination, right? Another way to ask this is, how would I make this from a 1, 2, 3, 4, 5? How would I make this from a 5-carbon, can you see that 5-carbon compound, right? How would I make that? And you just work your way backwards. You say, well, I know I can make a double bond, and I can do that with a strong base. This looks like it's the Hoffman product, right? Because it's the least substituted alkene. And so I could make that by a tertiary alkyl halide, right? So you work your way backwards like that. Go practice. Good luck.